Last year, over 30% of global deaths were due to an unseen battle going on inside our bodies. This threat kills even more people than cancer. But to tell you this story properly, we must first begin before the heat of the battle. This is your heart. It powers the flow of oxygen and nutrients into your blood vessels, keeping your whole body alive. But this system is the target of the world's top killer, cardiovascular disease. One major cause of it is the narrowing and blockage of blood vessels due to cholesterol, which can cause heart attacks and strokes. Let's have a closer look at what happens inside a blood vessel. In this cell village, the river provides the cells with all their food, livelihood, and joy. One of the essential components for the village's survival is cholesterol. There are two types, high density and low density lipoproteins, also known as HDLs and LDLs. But peace does not last forever. An imbalance in cholesterol, especially an excess of LDL, will spell disaster for the village.
Go forth, my nanofilters. Charge!
This is our nanofilter. We made it using DNA Origami, a technique used to create self-assembling nanostructures out of DNA. This device specifically targets LDL cholesterol and captures it from the bloodstream. The structure is made of 7 nodes with LDL cholesterol binding sites on each one. There are also flexible linkers between each node, allowing the nanofilter to curl in a prescribed direction. Both the top and bottom of the unfurled structure contain single-stranded DNA sequences called handles. These handles are bound together with locking strands, forming double-stranded DNA and allowing the entire structure to remain in the locked state. The nanofilter is then introduced into the bloodstream. One end of it binds to the inner surface of a blood vessel, and the force of blood flow breaks the bond with the locking strands. This results in the structure unfurling and exposing the LDL binding sites. LDL cholesterol then attaches to these sites, causing the nanofilter to roll up again, securing its cargo. Crucially, this bond is stronger than the initial locking strands, so it won't break due to blood flow. The captured LDL can no longer build up on the vessel wall. The nanofilter containing the cholesterol will then detach, and additional markers on it could promote excretion by the liver. There are more dangers on the horizon, waiting for our wizard and his village, but the nanofilters are more than ready to take on the challenge. Whatever the pathogen, toxin, or threat, all that is needed is to change the binding site to target a different molecule. So now, the only question is, what do you want to capture?